Welcome to the section of regression. I'm really excited that we're really finally getting into machine learning algorithm right now. The first part that we're going to look at is regression. In this section, what we're going to look at is, first of all, the different categories of machine learning. We're going to talk about the different types and how to actually make use of them and to solve what problem. I'm going to introduce to you the scikit-learn library for Python. This is the library that we will use predominantly to solve all of our challenges, the real-world challenges that we're faced with. On top of that, we're going to start applying all of the things that we learn on what we call Boston housing prediction, real-life data, and just basically performing exploratory data analysis and then correlation analysis as well as feature selection to begin with for the Boston housing prediction. Now, the various types of regression machine learning algorithm that we will actually go through will be robust regression to actually pick out the outliers and also figure out what the inliers are. Multiple regression with using the stats modules. This is a gentle introduction for those who come from a statistic background. We're going to cover multiple regression as well as picking out the most important features. That's what's called feature importance. Of course, we'll look at ordinary least square and also making use of gradient descent, which is a really important optimization algorithm. And we're going to look at regularized regression on how to restrict your model so that it doesn't overfit. So this is going to cover ridge, lasso, as well as elastic net. But the important part that I want you to know is that while these principle is predominantly applied to regression, it actually will come back again and again when we actually start to talk about other machine learning algorithm as well. The same so-called principle and concepts apply across all of the different machine learning algorithms, including classification as well. And we start to slowly move into polynomial regression, which start to fit models that are not linear, and we're going to evaluate our performance or the performance of our algorithm as well, because that's really the key part. That is that we want to know how it will perform when it's dealing with data that has not seen before. Typically, you have training data for you to actually train your machine learning algorithm, but the important part is how does it perform when it's out of sample. I'm really excited about this part. I'm going to give you some gentle introduction or brief introduction on decision tree, random forest, some of the more state-of-the-art machine learning algorithms such as AdaBoost. These help you to deal with nonlinear regression, nonlinear relationship, in contrast to all the other regression models that we looked at. And finally, we will also look at extracting the important features from using either random forest or AdaBoost for that purpose. The other key components that we look at, not necessarily restricted to the regression portion, is data preprocessing. By and large, for most machine learning algorithms, you do need to pre-process your data. It actually makes the assumptions that either your data is between -1 to 1 or 0 to 1. That's where the standardization, min-max, normalization, binarization, as well as converting your data from text or strings to 0 and 1. The reason being, most of the machine learning algorithm or library out there don't know how to handle strings. That's why we will make use of label encoder, which converts strings to numbers, or binarize them if it's only two numbers, binarizing them to 0 or 1. And we'll also talk about one-hot encoding on how to deal with multiple class problems and try to resolve the problem of if it's 0, 1, 2, 3, where typically machine learning algorithms is going to put more weight onto 3 rather than 0. That's where we make use of one-hot encoding for that purpose. We'll talk about some of the challenges you will face, what's called variance and bias trade-off. Variance meaning there's a lot of deviation or a lot of variability to your data or your machine learning or your machine learning algorithm's prediction. Bias means that is almost constantly wrong. Well, a high bias model is obviously not good because it's never get it right. High variance means that you can't trust it because it constantly gives you signals that sometimes it's good, sometimes it's no good. So that's really, you can't get any confidence out of the prediction that comes out of it. This is the part that we're going to talk about validation curve and learning curve and how to deal with it. And also finally, we will make use of cross-validations such as holdout cross-validation, K4 cross-validation, and also stratified K4 cross-validation. All of these are to help you to gain some confidence of your model on how it's likely to perform when you start looking at real-world data. Now, there's a lot of contents in this portion, and really the approach that I've taken in this portion is to build up concepts one by one, step by step. Later on, when you want to, you can actually pop back to the data preprocessing, look at the cross-validation or the variance bias trade-off. You don't necessarily need to come back to this portion just for the regression. You can also come back here for all the other components as well. So with that, that's really the end of the introduction. I can't wait to see you in the course itself. Thank you for watching.